Okay, let us see how we handle this question here. A boy who can swim at, this is the rest of the boy, so we read and summarize. So the boy can swim at a velocity of 2 meters per second in still water, which should swim across a river. So the river is 250 meters wide. If the river flows at the velocity of the water in the river is 1.5 meters per second. Find the time it takes the boy to cross the river. How far down the stream the boy travels. So that's the case. Now we come for our part A. So this is our river there. To cross the river and how far. So this is our, assuming that our boy is here. This is the point opposite. So he wants to cross the river. So if he wants to cross, that's going to be how far he will go downstream. Remember, now this one is going to be our velocity of the boy, which is 2 meters per second. And then here is going to be the velocity of the river, 1.5 meters per second. And this will be our result. So they want us to get the time it takes the boy to cross the river. So to get this time, now, by the way, they are giving us the width of the river, which is 250 meters. So it means that now to get how far this boy will go, we need to get the result from here. This is going to be the distance, how far we go from this point. And then we also need to get this from here up to there. So this is going to be our theta. Then the position set is alpha. What we are going to do, we are going to use this and this to get the resultant velocity. So our VR is going to be the square root of 2 squared plus 1.5 squared. Our resultant velocity is going to be going to be 2.5 meters per second. So that's the resultant velocity. Now, we want also to get this SC here. Because the time it's going to take, the velocity is going to use, then also the distance. Okay. So what are you going to, you know that we have this, So if we have, but also have this, we have this, and then we have this. So this is adjacent. This is the hypotenuse. Okay. So you know that our cos theta is going to be the adjacent 2 over the hypotenuse, which is 2.5, equaling also the adjacent, which is 250, over the hypotenuse, which is AC. So from there, I supply AC is going to be 250 times 2.5 down over 2. So my distance SC is going to be going to be 312.5. These are going to be meters. So that's my SC. So therefore my time will be equal to SC over VR. So my SC 312.5 over 2.5. This will be seconds. So my time will be 125 seconds. So that's going to be the time that man is going to use. And now from there, find the course, find the time it takes, how far down the stream it goes. So how far down the stream, this is what we want. So there we can use, if that we have this, we need this. So at the down the stream, you can say that our tan theta is going to be, first of all, opposite over adjacent, which will be equal to the opposite in terms of the distance, BC, over the adjacent, which is 250. Then if you cross multiply, that our BC is going to be 1.5 times 250, the whole over 2. So my BC is going to be from there. It's going to be 187.5 meters. So that's going to be my BC. Okay, so now part C, the one that's the course he must set in order to cross to the point opposite to his initial direction. So there, if you would like to get the opposite, then we change the sketch. So he wants to go there from A to B. If he's doing that, then he has to take that course. Let us call it beta. And then the velocity is going to use, of course, the velocity at which is swimming, 2 meters per second. And then from here, we are going to be adding the velocity of the river, which is 1.5 meters per second. So the course we must set is this part. First of all, we first get this theta, then after we shall get there. So we have opposite, this is going to be our hypotenuse. So there we are going to use opposite hypotenuse sine theta. Our sine theta is going to be the opposite over the hypotenuse. So from there, our sine theta is going to be 48.59 degrees. And then, if I have theta, therefore my beta will be 90 minus theta, which will be 90 minus 48.59. So from there, my beta is going to be 41.41 degrees. So this is the course, therefore. The course is already set to the bank. Course is 41.41. Okay, and then they're asking, and the time it takes. The time it takes, this is going to be our VR. The time it takes, we need this divided by that. Okay, so we need to get now this VR, then we get there. So our VR, you can see that when I get VR squared plus 1.5 squared, giving us 2 squared. So my VR is going to be the square root of 4 minus 1.5 squared. So my VR is going to be, oh my goodness. So it's going to be 1.32 9 meters per second. So if we get that divided by there, our time will be AB over VR. Our AB is 50, and then 250 over 1.329. So my time taken is going to be 188.9788 seconds. So that's the time it's going to use to cross this river there. So that's it, members. I wish you well.